Hello, ladies and gentlemen. Welcome back to Math 31 Calculus, Chapter 1, Lesson 7, the second part. It's actually video number 4, Limits at Infinity. Now, this gets a little confusing, so pay attention. Now, considering solving the infinite limit as x goes to infinity of 1 over x. What happens? Well, look at the table of values in the graph. Make it clear that as x goes to infinity, f of x goes to 0. And we have a horizontal asymptote at y equals 0. Okay? Now this goes back to Math 30. Think of this as f of x, where g of x is a greater power, bigger degree, than f of x. Now, similarly, using the properties of limits, the limit as x goes to infinity of 1 over x to the n equals the limit as x goes to infinity bracket 1 over x close bracket to the n, which is equal to bracket limit x goes to infinity 1 over x close bracket to the n power. Now, since we have shown that the limit of x going to infinity of 1 over x is 0, we can conclude that the limit of x going to infinity of 1 over x to the n is 0 for n greater than 0. Now, I got to stress that greater than 0, that is positive. What happens if you have a negative root? It flips, and this becomes the limit of x to the n. And that's a problem. Anyway. Now, we can use this finding to solve the limits of rational functions. We divide the numerator and the denominator by the highest power of n. Let me show you. So, look at this. Now, if I taught you Math 30-1, I taught you just to look at the highest powers. And there's actually a lovely calculus lesson here. When I say evaluate the limit as x goes to infinity of 7x cubed plus 4x divided by 2x cubed minus 2x squared, minus x squared plus 3. What I want you to do is divide everything by the highest power of x. So this is the limit as x goes to infinity of 7x cubed divided by x cubed plus 4x divided by x cubed. Now notice I'm not changing this. I'm just dividing everything by x cubed, which is fine. Now, why do I do that? Well, let's see what cancels out. X cubed and x cubed, x cubed and x cubed. Now, what else? Well, 4x divided by x cubed, what happens as x goes to infinity? That becomes 4 divided by x squared, which is 4 divided by an infinitely large number. This becomes 0. Similarly, down here, x squared divided by x cubed becomes, let me emphasize, that becomes 1 over x. What happens as x goes to infinity? That goes to 0. Same thing here, 3 over x cubed. As x goes to infinity, that becomes a huge number. That becomes 3 over a huge number, which becomes 0. So all the other numbers cancel out, and we're down to the limit as x goes to infinity of 7 halves, because everything else is canceled out. And here I can do simple substitution. 7 halves. So we have a horizontal asymptote. Y equals 7 halves. That's what I need to be able to see and do. Difficult? Well, I hope not. Same thing. No, I shouldn't get so trite in saying difficult, yes, no, because of course I'll be an arsehole. Now, something like this, typical calculus question, what do? Well, you're going, holy crap, you got to multiply it out. Which sucks, but the limit as x goes to infinity. Now, that's minus, let me see, it'll be n squared plus 4n plus 4 over 5n minus n squared. Limit as x goes to infinity, negative n, the other m. God, everything becomes opposite, Mr. Sutton. And then we divide everything by our highest power. N goes to infinity. Sorry, gentlemen. I can hear you screaming at me now. My bad. Now, I'll have to go back and fix that. That's the limit. N goes to infinity. Now, so let me see. That becomes minus 1. That becomes 0. That becomes 0. That becomes 0. That becomes minus 1. So this is the limit as n goes to infinity of minus 1 over minus 1. Just 1. Not bad, eh? Once you see the trick. Now, for the find the following limits if they exist. Use a table of values. All right. So, first one, limit is x goes to infinity of minus 1. Zero, 1, 2, 3, 4, 5. 0 minus 1 to the 0 is 1. Minus 1. Minus 1 squared is 1. Gives minus 1. Minus 1. Okay, I'm going to say limit does not approach. Limit does not approach a finite value. Hence, it does not exist. Does not exist. All right. Now the next one. Limit of half as x goes to infinity. Or sorry, 1/2 to the nth power. Okay, so that is 1/2 to the 0 is 1, 1/2, 1/4, 1/8, 1/16, 1/32. Okay, I'm comfortable saying that's going to infinity. Oh, sorry, that's going to 0. It's going to go there. Yeah, I'm comfortable saying going to 0. It's getting smaller, 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 smaller. Now, if you don't like that, oh, by the way, you should have cheated and drawn the graph for all of these. This one goes like that. This first one, you can't graph a graphing calculator because it bounces all over the place. All right? Now, how many of these do we have? Actually, I'm going to pause the recording here. We'll come back and do the last examples in the last video. So take a look at this, think about it. If you got any questions, shoot me an email. And remember, draw the damn graph if you can. Any questions, shoot me an email. Otherwise, good luck.